Hello my dear students, now we can start this chapter electrochemistry. It's a very interesting chapter and my dear students, one question is always asked in NEET exams. So in crash course my dear students, we can start the electrochemistry chapter and first of all my dear students, we can here see the important formulas which are used in this chapter. My dear students, you can see in electrochemistry questions, previous year questions, maximum numericals are asked in this chapter. Only one or two questions are in theoretical. So, my dear students, first of all, we can learn the all important formulas which are used in this chapter. Now, number one, my dear students, important formulas here, important formulas which are used in these chapters. Here my dear students, important number one is we can write here delta G is equal to minus NFE cell. Here my dear students, what is the delta G? Delta G is the change in free energy, change in free energy. Delta G is the change in free energy and this is called as at standard state. At standard state. And what is the N, my dear students? N is the number of electrons. Number of electrons take part in the reaction. Part in the reactions. And what is the E, my dear students? E naught cell. E naught cell is the EMF of the cell. Now here all other formulas in which N is present, it is taken as a number of electrons. Number two formula, my dear students, that is the E cell, EMF of the cell, and this formula is given by the Nernst, so it is called Nernst equation. E cell is equal to E naught cell minus 0.0591 upon N, that is a log Zn plus 2 upon Cu plus 2 or product upon reactant. Now we can see here third formula. Here E cell that equal to E naught cell minus 0.0591 upon N log, this is the product upon reactant. It means, my dear students, that equal to Kc or that equal to Kc. You can also find out the equilibrium constant Kc by this EMF of the cell. Here we can use the fourth formula, my dear students. Here that is the E cell that equal to E naught cell, EMF of the cell at standard state. So it is called E naught cell minus 0.0591 upon N. N is the number of electrons involved in the reaction, and here log, here when pressure pH2, 1 atmosphere pressure is given or 1 atmosphere hydrogen is given in the solution and pH is formed, means after the pH you can get the H plus ions. So you can use this formula and calculate the E cell EMF of the cell. Now my dear students, fifth formula, here you can direct put this formula. So you can say here E cell that equal to E naught cell minus 0.0591 upon N log Kc. Here my dear students, in all the numericals which are given in the previous exams, these formulas are used. So my dear students, you can learn and remember these formulas. And sixth formula is delta G that equal to minus nRT log Kc. It is the relationship between the, my dear students, Kc equilibrium constant and delta G. So if delta G change in free energy is given, and you can calculate the equilibrium constant. Here my dear students, what is the E naught cell? Here E naught cell EMF of the cell at standard state. So you can given here at standard state. And what is the standard state, my dear students? It say 298 Kelvin and 1 molar concentration. So, it is called standard state. So, my dear students, you can learn these formulas which are used in your exams. Now, after these formulas, these 6 formulas which I given to you, my dear students, we can get the questions previous year. Now, number 1. This question is asked in Odisha, NEET 2019. The standard electropotential E naught values for AL plus 3 to AL, AG plus 2 AG. You can see here, these are the reductions take place, my dear students, K plus K, because here this chromium taken the electrons and converted into metal. So, here this reduction potential is given, and he is asking the order of reducing power of the metal. Now, what is the concept of this question? Concept. My dear students, more the negative value of reduction potential E naught reduction, more the negative value of E naught reduction, metal is reducing in nature. Metal is reducing in nature. So, this is the concept, my dear students. Here you can see the lithium. Lithium have minus 3.05 volt, and it is the strongest reducing agent. It is the strongest reducing agent. Then zinc. Here zinc minus 0.76 volt. In this way, my dear students, if you have these values is given by in this table or in this question, you can select the maximum negative value. This is the maximum negative value. So, it is the strongest reducing agent. So, my dear students, minus 2.93 value is given for potassium here. You can see here potassium. So, potassium is the maximum reducing metal. C or B. So, A and D is not correct answer. You can get the B and C. After B and C, you can get most negative value for this aluminum minus 1.66. So, after potassium, you can get aluminum, B and C. You can get both the answer B and potassium and aluminum. After you can see here minus 0.76 most negative value. It is for last, that is chromium. So, my dear students, your answer is B, question number 1, because according to value we are arranged, and we are arranged in this way: minus 0.93 is more values than more negative values, minus 1.66, then minus 0.74, then 0.80. So, my dear students, order is the B. So, correct answer is question number 1, correct answer is B. Now, we can go to the question number 2. A button cell used in the watches function as follows. Number 1, zinc solid Ag2O, water, twice Ag solid plus Zn plus 2 and plus twice OH minus. If half cell potentials are given, and you can get the, my dear students, half cell potential means electrons are added in these ions, means this is the reduction potential, and this Ag2O converted in this Ag means electrons are taking by this, it is also a reduction, and in which reduction potential negative values or less values are act as a anode. This is the concept, and act as a cathode, because in this question he want the cell potential. So, my dear students, what is the concept of this question? You can put the formula E naught cell, and it is a very easy formula, E naught C minus E naught A. But the put this formula A, anode, you can see here anode, this work as anode. So, put the formula, get the answer, plus 0.34 minus 0.76 volt, minus plus, then you can get the plus 0.34 plus 0.76, and you can get, my dear students, E naught cell, and that E naught cell you can get the 1.10 volt. So, here my dear friends, you can see here answer is that C. My dear friends, you can go this question number 2, answer C, 1.10 volt. Question number 2, NEET 2013, and you can get the answer. E naught cell 1.10 volt. Now, my dear friends, we can go to the question number 3. Here, standard reduction potential of the half reactions are given below. These are the half reactions, and you can see here electron is taking by this. So, these are the reduction here, reduction is occur. And my dear friends, I am also say before in my lectures, when any metal get the electron and form the anions, these reactions are the reductions. It is called reduction. Why? Because my dear students, when get the electron, oxidation number decreases. Here you can see the oxidation number of this fluorine, that equal to 0, and here oxidation number is -1. So, oxidation number decreases, it means reduction is done, and this values is given for the reduction values. So, my dear students, here you can see that this reduction potential value positive, had the positive reduction potential values. This is a concept. This is a concept we can write here. Higher the positive value, stronger the oxidizing agent. That agent or that element is stronger oxidizing, in which values of positive value is higher. So, my dear students, this is a concept. Now, we can see here positive values. Here this plus 2.85 volt. So, my dear students, strongest oxidizing agent in this reactions are the fluorine. Fluorine is the strongest oxidizing agent because fluorine have the plus 2.85 value. So, your answer is A. Why? Because fluorine is present only A option. It is not present in B, C and D option. That is why you can go option A. Now, we study this iodine. My dear students, here strongest reducing agent, though that weak oxidizing agent is the strongest reducing agent. Here which is weak oxidizing agent, in which value of positive is lower. That is why, my dear friends, iodine 0.53. So, you can go the iodide minus ion. So, question number 3, this question is also asked in MENT 2012, and question number 3 answer is A. Now, we can go to the question number 4. Here, my dear friends, question number 4, standard electrode potential of 3 metals X, Y and Z, and he asked the reducing power. Here reduction potential, maximum negative value is act as reducing power. So, here X, Y, Z, here this is the value of Z, here this is the values of Y, and here this is the values of X. So, my dear students, concept you can see -3 for X, it is a greater, negative value is greater. For negative values, no negative values. Okay, my dear students, for negative values you can get X -3, then you can get, my dear students, -1.2 for this is the -3 for Z, okay, not for X, it is a Z, Z for -3, Z for -3, -1.2 for this is X, and after this plus 0.5 volt, it is for Y. So, my dear students, order is this one, Z, X and Y, and this order is present in C option. So, my dear students, you can see the fourth C option is the correct answer. And this question is also asked in 2011. Now, we can go to the question number 5. Standard electrode potential for 10 Sn plus 2 means electrons are taken in auto reduction. Here you can see the chromium is converted to chromium, means these are called in auto reduction. and he want the cell potential. Here my dear students, concept is same, E naught cell that equal to E naught C minus E naught A. Here what is the E naught C my dear students? E naught C, what is the cathode and what is the anode? This is the question. Here my dear students, which is E naught direction is maximum positive values, it is act as a cathode. So, this is act as a cathode and negative values act as a anode. So, plus 0.15 minus 0.74, and you can write here plus 0.15 plus 0.74, then you can calculate the E naught cell, and this is you get the answer B 0.89. When both are added, you can get this answer. So, my dear students, you can go the question number 5th, option is B. Here, my dear students, you can learn the formula E naught cell that equal to E naught C minus E naught A. Here, my dear students, here E naught C, this is the reduction potential of cathode, reduction potential, and E naught A, it is the reduction potential of anode. So, my dear students, you can write here E naught cell is equal to E naught C minus E naught A. Now, we can see here question number 6. In question number 6, my dear students, a solution contains Fe plus 2, Fe plus 3 and iodide ions. The solution was treated with iodine at 35 degrees Celsius, E naught 4. Here you can see the Fe plus 3 is converted to Fe plus 2, and he give the E naught plus. Now, here you can see the here electron is taking and here electron is taking, and it is converted to 0.536 volt. He want the favorable redox reaction is. What is the favorable redox reaction? So, my dear students, what is the concept? Those reactions in which E naught positive are favorable are spontaneous reactions are favorable reaction. Number 1 point. Number 2 point, my dear students, when both are positive, then in which maximum value of values of E naught is present, E naught positive is present, more favorable. So, my dear students, here you can see the 0.77 is greater than 0.53. My dear students, it is a more favorable. So, you can go to this favorable redox reactions. But in this favorable redox reaction, my dear students, question is that iodine will be reduced to iodide minus ions. Because here iodine is reduced to iodide minus ions when this is favorable. So, it is not a correct answer. There will be no redox reactions. Or C, iodine will be oxidized to iodine. Yes, this iodide, because it is not favorable for this, so it is oxidized to this. Or Fe plus 3 is converted to Fe plus 2, but in D option, here you can see Fe plus 2 will be oxidized to Fe plus 3. Here it is a favorable to Fe plus 3 to Fe plus 2, but here this is Fe plus 3 to Fe plus 2, it is not favorable because in E positive is higher. So, my dear students, you can see the question number 6 answer is C. You can solve this question by the concept of, if you have this concept, then you can easily solve these questions. Now, my dear students, we can go to the question number 7. Here question number 7, consider the following reactions for EMF of an electrochemical cell. What is the concept, my dear students? Here you can see the first of all concept. Number 1, in electrochemical cell, E naught cell that equal to E naught cathode minus E naught anode, but both are reduction potential. And my dear students, you can see here E naught reduction potential that equal to minus E naught oxidation potential. So, my dear students, when you see this question and consider the electrochemical cell, you can apply these formulas, and when you can apply this formula, you can go two types of values and formulas to get the EMF of the cell. Now, we can say here in second EMF of the cell that oxidation potential of anode plus reduction potential of cathode. This is correct, because this is the E naught cell that equal to E naught oxidation potential, because oxidation is done in anode. So, it is oxidation potential plus E naught reduction potential, because in cathode reduction is done, and when both are added to give E naught cell. Because my dear students, we can see this type of formula is derived from this formula, original formula this one. So, second is correct answer. Now, we can see the fourth option, oxidation EMF of the cell, oxidation potential of anode and minus the oxidation potential of cathode. Because my dear students, when you can put this formula, E naught reduction potential is always equal to negative sign minus oxidation potential. So, when you can put the oxidation potential of cathode, then my dear students, you can put the minus E naught oxidation potential of cathode. So, you can get the E cell that equal to E naught oxidation potential of anode plus minus 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 E naught oxidation potential of cathode. In this way, my dear students, you can solve. This is also correct, and another EMF of the cell, oxidation potential of anode minus reduction potential of cathode, wrong. So, you can go the answer D, and you can learn this formula, number 1 this, number 2 this, and number 3 this, number 4 this. And you remember these formulas, and these formulas are always used in your electrochemistry chapter. This question is also asked in MEN 2010, my dear students. Now, we can go to the question number 8. Here you can see that question number 8, on the basis of the following E naught values, the strongest oxidizing agent is. Here, my dear students, what is the concept? Concept is that here option is Fe plus 3, FeCN whole 6 minus 3 and FeCN whole 6 minus 4 and Fe plus 2. Here, my dear students, when you can get the Fe plus 3 means reduction potential, this electron is added, then this reduction potential is reversed. First of all, when you can reverse the reduction potential, then you can get the strongest oxidizing agent. Means strongest oxidizing agent are those agent in which maximum positive values of reduction potential present. So, my dear students, here when these both are accept this electron and from this the Fe plus 3 plus electron to get Fe plus 2 and reduction potential is equal to E naught is equal to plus 0.77 volt. Now, my dear students, and this is the reduction potential. When you can see both are accept each other, FeCN whole 6 minus 3 accept this electron and reduction is occur and convert into FeCN whole 6 4 minus, then E naught reduction is the opposite of this. This is a plus 0.35 volt. And you can see what is the strongest oxidizing agent. Maximum values of E naught reaction percent is the oxidizing agent. So, you can see here plus 0.77 volt is the maximum. So, my dear students, you can go the option A. Question number 8, option is A is the correct, and concept is this. This question is also asked in 2008 NEET exams. Now, my dear students, we can go to the question number 9. Here we can see a hypothetical electrochemical cell is shown below. Here A is converted to A plus, my dear students, and here this is the concentration X molar. Here B plus is converted to B, here this is the concentration. And EMF measured is 0.20, the cell reaction. Cell reaction is a very easy, and this question is a very easy question. It is asked in 2006. Here, my dear students, A, you can write here A in left hand side plus salt, this is a salt bridge, you write here B plus for this cathode, this is anode, this is cathode, and this is arrow. After this arrow, it is converted to A plus, and it is converted to A plus in this way, B plus converted to B, and this is the reaction, my dear students. A plus B plus to give A plus B, and question number 9th you can get the answer A. It is a very simple question. It is a direct question which are asked in 2006. In this question, this is called salt bridge. This double one is called salt bridge, and these are the concentration, electrolytic concentration. Now we can go to the question number 10. My dear students, here question number 10. This question is also asked in 2006, my dear students. It is a very interesting questions, and calculation is there. Here you can see the required reaction is Fe plus twice Fe plus 3 to get thrice Fe plus 2. He asked the EMF of this reaction, E cell of this reaction he asked, and he give the two reactions. Number 1, this Fe plus 2 is converted to Fe, and this is the E naught. Here we can say the Fe plus 2 electron to convert to Fe, and E naught is minus 0.441 volt. Now number 2, here you can see the Fe plus 2 to give Fe. Here when we see the reaction of this main reaction, this Fe is present in product side, and here required reaction it is present in reactant side. And my dear students, in second reaction this Fe is not present. So first of all you reverse this reaction. This reaction is reverse, and you can get the Fe to give Fe plus 2 electron, and this sign is reverse, plus 0.441 volt. Now we can get this second reaction Fe plus 3. My dear students, this Fe plus 3 is reactant side, and it accept 1 electron to convert into Fe plus 2, because this reaction is given in this EMF. This is the 0.771 volt. My dear students, here you can see the reaction. Twice Fe is present here. So this is multiplied by 2. Here this is multiplied by 2. When you can multiply by 2, twice Fe plus 3, 2 electron is there, and 2 Fe plus 2. My dear students, this EMF is the intrinsic property. EMF is the intrinsic property. It is not depends upon the number of electrons. So my dear students, you can write here intrinsic property. Here you can not multiply by this. It is not, this is intrinsic. It is not an extrinsic property. So it's not depend upon the nature or numbers. So my dear students, you can not multiply by 2 here. Now we can add both the equation. This is the, when we add both the equation, twice A cancelled with each other. Here you can see Fe, twice Fe plus 3, right? This is the twice Fe plus 3, and here you can get the 2 plus 1, 3 Fe plus 2. My dear students, you can get the reaction, and this is the same reaction. So, if you add this EMF, then you can get the answer. No, not, my dear students. This is our converted into free energy. Now, it is a G3, my dear students. This is a G1 and this is a G2. We can calculate it by the free energy. G3 is equal to G1 plus G2. And free energy is the, my dear students, minus NFE cell. Here NFE1, here my dear students, minus NFE cell NFE2, and here this is called minus NFE3. In this way you can calculate the E. By G you can calculate the E. Here Faradays are cancelled with each other. So, you can get the number of electrons, moles of electrons. Here you can put the values minus N E3, that equal to minus N E1 plus here minus N E2. Now, you can put the number of electrons here, my dear students. For N, here you can see here only 2 electrons are participated here. So, 2 electrons are participated. So, it is here 2 electrons, N is equal to 2. Here you can see the N is equal to 2, here N is equal to 2. So, my dear students, here you can put the this N is equal to 2 into E3, that equal to 2 E1 plus minus minus 2 into E2. Now, you can put the values minus 2 E3, that will be minus 2 into E1. What is the value of E1? E1 value is the minus 0.441, and minus these are cancelled with each other. So, you can get the 441 plus. Here you can put the 2 into values of E2. What is the values of E2, my dear students? Here this is the reverse. So, minus is completed in plus. So, yes, you can write the here plus. Minus 2 into E2, what is the value of E2? 0.771. You can put the values of 0.771. Now, my dear students, here you can calculate this values E3. Then, my dear students, E3, 2 E3 you can calculate, that is 2.424, and when this E3 is equal to 2.424 divided by 2, this is a 2 E3. So, my dear students, you can get the 1.212 volt, and this is the answer of your question. Question number 10th answer is D. My dear students, you can calculate these questions by the using of formulas. First of all, required formula, you can required reaction you can write here. Then you can write the reactions from the EMF of the cells and convert into G and add and calculate this E3. And you can, this E3 is the E cell, E3 the EMF of the cell for this reaction. This is E3 the EMF of the cell, that is 1.212 volt. So, my dear students, you can, I hope you can understand. First of all, these are converted into free energy. You can calculate the N. Here, my dear students, 2 electrons are taking part. Here 2 electrons are added or evolved. So, N is equal to 2 here, you can put here. And these negative signs are cancelled. So, you can cancel this negative sign and you can put the here, you can get the 2E3 is equal to 2.424. Now, my dear students, we can go to the question number 11. Here question number 11 you can see here, that is standard electrode potential, same, Fe plus 2 to Fe, E naught is given Fe plus 3 to Fe, E naught is given 0.77, here minus 0.44, and Fe plus 3 and Fe blocks are kept together, then which is increases or decreases concentration. Now my dear students, what is the concept? First of all, at anode, you can see the anode, Fe is converted into Fe plus 2 and 2 electrons are evolved at anode, and here Fe to Fe plus 2. Here you can see here minus 0.44 volt is given for, that is Fe plus 2 is converted to Fe, but at anode reaction is reverse. So, E naught is also reverse. So, E naught is also reverse. Then you can say E naught is equal to plus 0.44 volt, because anode you can, iron is converted to Fe plus 2. Now we can see the at cathode. At cathode, my dear students, this Fe plus 3 is reduced by the electrons. These 2 electrons are taken by this Fe plus 3. Yes, you can take that twice Fe plus 3 to give the twice Fe plus 2, twice Fe plus 2, and E naught is given by, that is the 0.77, because here this Fe plus 3 is converted to Fe plus 2 and that is 0.77. Now my dear students, when you can add this, both are anode and cathode values, then you can get the 2 electrons are cancelled with each other. You can get the Fe plus twice Fe plus 3 to give this thrice Fe plus 2, 2 plus 1, here 2 plus 1, thrice Fe plus 2. My dear students, here you can see the, when you put this 0.77 is greater than 0.44, and in this reaction Fe plus 3 is converted into Fe plus 2. In this section you can see Fe plus 3 is converted to Fe plus 2, and question is that Fe plus 2, Fe plus 3 and Fe blocks, these are the iron blocks, and these blocks, iron blocks, are kept together in the H2SO4. What will happen? At anode, iron is converted to Fe plus 2 and Fe plus 3 is converted to Fe plus 2. So, my dear students, you can see here Fe plus 3 concentration is decreases, because this concentration is converted to Fe plus 2. So, your answer is question number 11, answer is your B. B is the correct answer, because these are act as a cells, these blocks are act as a cell. At anode, oxidation is occur. So, when oxidation is occur, iron is converted to Fe plus 2, because here you can see the E naught cell Fe plus 2 Fe, but here Fe is converted to Fe plus 2, then this minus is converted to plus, and it is act as anode. And when Fe plus 3 is converted to Fe plus 2, yes, and it is act as a cathode. So, my dear students, total reaction is occurring this way. So, here my dear students, here concentration of Fe plus 3 is decreases, and this question is asked in 2001 NEET exams, question number 11. Now, we can go to the question number 12. Here in question number 12, electrode potential for the following half cell reactions are, and this calculate the E naught cell or E cell of the reaction, and reaction is given Fe plus 2 plus zinc to give Zn plus 2 plus Fe. My dear students, you can see here first reaction is Zn to give Zn plus 2 electron plus 0.76 volt. Here Fe to give Fe plus 2 Here my dear students, you can see here in this reaction you have two reactions. Number one, Zn to give Zn plus 2 electron, here E naught that is equal to 0.76 volt. Zinc is present in reactant, yes, here this is reactant. Now number 2, this iron is present in product, here reactant, that is why my dear students it is reverse, and you can get Fe plus 2 electron convert to Fe and E naught plus 0.4, then it is reverse. It is obtained minus 0.44 volt. Now my dear students, when you can add this, you can get the Zn, and these are simply cancelled with each other. Fe plus 2 to give Zn plus. Here my dear students, this is act as a anode and it is act as a cathode. Here this is the electrochemical series and these are the two half cells. When two half cells are added with each other at standard state, then you can see the E naught cell that equal to E naught C minus E naught A. Here my dear students, when you see the E naught C cathode is the cathode E naught C and E naught A, then my dear students it is a 0.76 minus 0.44 and it is a convert to plus, then you can get the 0.32 volt. Because my dear students, here this zinc and iron, here you can see this cathode is work 0.76 volt, this is zinc because value is lower higher and this value is lower for reduction, and so my dear students it is a act as a anode. So in anode you can put the values minus 0.44 volt, minus 0.76 volt, because it is a cathode, it is work as a cathode and it is work as a anode, and you can get the answer 0.32. This question is also asked in 1996. Now we can go to the question number 13. An electrochemical cell is set up. Here you can see the HCl concentration is 0.1 molar. Here it is a 0.1 molar, same concentration present. The EMF of this cell will not be 0 because, but it is not a 0 when this concentration is same. What is the reason? Acid used in two compartments are different. EMF depends on molarity of acid used. The temperature is constant, or pH of 0.1 molar HCl 0.1 molar is not same. Yes, this is the answer, because concept HCl is a strong acid, so it is 100% ionized, but acetic acid is a weak acid, so it is not 100% ionized. So my dear students, here this cell will not be a 0 potential. This is the answer and this is the concept. So your answer is question number 13, answer is D. Now we can go to the question number 14, my dear students. Same question is here, strongest oxidizing agent. Which is the strongest oxidizing agent? Concept. Strongest oxidizing agent have less negative value of E naught reduction. So here you can see the minus 3 point lithium, minus 2.9 barium, minus 2.7 sodium and minus 2.37 magnesium. So my dear students, Mg plus 2 is the answer your question, and this is the concept This concept is already we can study. Then you can go to the question number 14. B option is the correct answer. Now, my dear students, we can go to the question number 15. A solution of potassium bromide KBr. Solution of potassium bromide KBr is treated with which one of the oxidizing agent to give bromine. You can react with Cl and you can get twice KCl plus Br2. Why? Because, my dear students, it is a strong oxidizing agent than bromide ion. So, bromide ions are converted to bromine gas and it oxidize this chlorine bromide ion. So, it is converted to bromine gas. So, my dear students, your answer is B. Question number 15, answer is B. Question number 15, answer is C, chlorine.